Number 5. The most distinctive property of the noble gases is that they are... Now, for some reason, I've been getting students asking me about this word radioactive here. And if we have enough time in the course, we will talk about radioactivity. It's kind of one of those things at the end if we have time. But what strikes me is that we haven't really talked about this, and students are kind of assuming because they don't know what it is, it's probably the answer. And that's simply not the case. If it's something that we haven't ever heard of, it's probably not the answer. We have heard the word metallic, okay, but these are noble gases. And the noble gases are on the right side of the periodic table. They are, in fact, non-metals. Look at you. Metalloids. Okay, metalloids follow the step staircase. Kind of go down here through kind of like the middle of the P block, kind of in a crisscross stair-step pattern. And the reason they're called metalloids is because they are not metals, but they are very like metals. In fact, they kind of share characteristics of metals, some characteristics of metals, but not others. For example, one of the most notable ones, we know that metals are good conductors of heat and electricity. The metalloids are what are known as semiconductors. They conduct heat and electricity a little bit, but not that great. And so you can see that specific characteristic we just mentioned, conductivity, is an intermediate between the metals, who conduct heat and electricity very, very well, and the non-metals over on the right side of the periodic table that do not conduct heat and electricity very well at all. And so, being a metalloid, that would mean that a noble gas does in fact conduct a little bit, and it does not. Okay, it is a gas. It's a non-metal. It's on the right side of the periodic table. Does not have that conductivity characteristic. And so we're left here with largely unreactive. But this builds into our idea of an octet, right? When we have our S and P sublevels completely filled, all right? And that's going to be a total of 8 electrons, right? 8 electrons. That connects us back to this word octet. When we have that full octet, that is a very stable electron configuration. Okay? It's a very stable electron configuration. So because the noble gases have this stable electron configuration, because of the full octet, because of the S and P electrons, S and P sublevels both being completely full, we get a type of element that is largely unreactive.